The next thing after the algebra of numbers is the Argand diagram, or the way to represent complex numbers on the XY axis, which is called the Argand diagram. So normally the Cartesian plane has got X and Y as the two axes. When representing complex numbers, we need to remember that this plane translates to the x-axis being the real axis and the y-axis being the imaginary axis. So the same way we would represent points on the xy plane, a complex number, for example 3 plus 4i, can be represented as a vector on the Argand diagram. So 3 plus 4i would be that complex number, so that the coordinates of this point are 3, 4. So it does mean that a complex number which has both parts as positive would be found in the first quadrant. Complex number with the real part negative and the imaginary part positive would be found in the second quadrant, and in the third quadrant both parts would be negative. So a complex number like 3 minus 4i would be found here, and one with the real part positive and the imaginary part negative would be found in the fourth quadrant here. So a number like 3 minus 4i would be found there, and it would still be the same as in the first case, where you treat the origin as just the origin, and you treat the two parts, the real part as the x value and the imaginary part as the y value. Once we have represented numbers like this, then there are a few other things we can do with them and end up expressing these numbers in other forms. The most common form in this case being the polar form. So if I want to express a complex number in the polar form is basically the form 3 plus 4i, for example, can be written as r cos theta plus I sin theta, where r is the modulus of the complex number, which in this case would be found as the length of that line segment when that complex number is represented on the Argand diagram. So this point here being 3, 4, if we call this complex number z, so if z is 3 plus 4i, then the modulus of z, which we represent as that, is the square root of 3 squared plus 4 squared, which is 5. Which is the same way we would actually work with vectors if we thought of this complex number as a vector. And theta in this case is called the argument, and this is the angle theta which the complex number makes with the positive x-axis. So in this case, theta would be that angle which our complex number z makes with the positive x-axis. By remembering that we know the coordinates of that point, we can of course find the value of theta by using trigonometry, because I know that the tangent of theta is 4/3, and that means theta is the angle whose tangent is 4/3, and we can find a value for that. So the polar form of a complex number is basically this form here,